Cost of ownership analyses helped us to identify optimal preventive maintenance schedules, resulting in annual savings of $20 million worldwide.
Too Cool helps us reduce costs and avoid unnecessary spending. In one case, it saved us over $2 million on a single purchase.
Too-Cool cost of ownership helps us to effectively manage our multi-billion-dollar capital asset portfolio.
These are just a few of the comments that have been made by Fortune 500 firms regarding the value that Too Cool cost of ownership and overall equipment efficiency software has brought to their organizations. Over the past 30 years, cost of ownership has migrated from an evangelical topic at a few select firms to a highly integrated part of corporate cultures. The driving force that propelled cost of ownership into the limelight was the severe disadvantage U.S. manufacturers faced during the 1980s in their cost of capital. They needed a tool to help them employ their higher cost assets more efficiently. Cost of ownership proved itself successful and has since been adopted by thousands of manufacturers and suppliers regardless of geographic location. Cost of ownership is an implementation of activity-based costing that helps in understanding all costs associated with a decision. It improves decisions by relating costs to the products, processes, and services that drive the cost. Without such a linkage, it is difficult for organizations to understand the full impact of their decisions on their operating cost structure. With this linkage, cost of ownership provides a consistent, data-driven method for arriving at important strategic and operational decisions. Cost of ownership provides an objective analysis method for evaluating potential solutions. First, it provides a clear estimate of lifecycle cost. The analysis highlights details that might be overlooked, thus reducing decision risk. Cost of ownership can also evaluate process and design decisions. Finally, cost of ownership provides a communication platform between suppliers and their customers. They are able to speak the same language, comparing similar data and costs by using the same analysis methods. Both suppliers and manufacturers can work from verifiable data to support a purchase or implementation plan. Developing a cost of ownership analysis strategy and re-engineering business processes identifies opportunities for using cost of ownership results to support management decisions. There are a large number of questions that cost of ownership can answer. Which supplier provides the most cost-effective equipment or consumable? Should we purchase higher capacity equipment to support future production? What is the impact of a change in materials at a process step? What is the impact of a component change or upgrade in process equipment? Does the equipment upgrade provide a positive return on investment? Which yield improvement project has the highest overall value? What is the impact of process parameter changes? What is the impact of changes to equipment operating conditions? What are the costs of idle time, downtime, and setup time? Should we replace existing equipment with new equipment? Can answers to these types of questions help optimize your operations? Our customers say they can. Let's take a look at one of the most common questions that cost of ownership can help answer.
I need to purchase a new piece of equipment. From which supplier should I buy?
In this example, we will look at comparing two pieces of equipment used in photovoltaic manufacturing. Both equipment types have been selected by equipment and process engineering as meeting all the technical and support requirements. It now comes down to which solution will add the least amount of cost to the manufacturing flow. We won't go through building each of the models as that is covered in subsequent videos. Instead, we'll concentrate on the benefits of using cost of ownership to help make decisions. First, we need to select which models to compare. In this case, they are two different deposition furnace solutions, one that is inline and one that processes product in batches. Next, we look at the input data to see where there are differences. In the case of the factors primarily under the control of the factory owner, we see the only difference is the lot size, which is a function of the difference between an inline and batch system. Looking at the model-specific data, which is primarily under the control of the equipment and material suppliers, we start to see some differences in maintenance, reliability, as well as throughput. There's also a difference in depreciable costs and initial training. We can see significant cost differences in the supplies and consumables usage, but we'll see that more clearly when we look at the final output report. Those are the differences outlined in the two cost of ownership models. Of course, the real value in doing this type of competitive analysis is the comparative results. Let's take a look at the management report. We saw a number of differences in the input data, but how big of a cost difference does that really drive? We can see the inline furnace has an advantage in depreciable costs, utilization, units out per week, and what may be surprising to some, almost a 4 times lower cost per good unit produced. Previously, we saw a big difference in supplies and consumables inputs, and looking at the Pareto analysis of the cost per good unit, we can see that a significant part of the total cost difference comes from this area. In this case, if all else is equal, it would be a very easy decision to purchase the inline furnace. In other cases, the costs and operating parameters may make it difficult to determine which solutions have the lowest cost of ownership. Should you buy a lower price equipment that has a lower reliability or slightly lower throughput? In the end, the benefits of using cost of ownership as part of a comprehensive process and equipment decision matrix are the ability to incorporate a standardized methodology across the organization that drives down decision time and risk. This approach is not subject to potential loss of knowledge that takes place with personnel turnover using homegrown solutions.